All right, welcome to section 11.4, selecting and drawing conclusions from samples. Let's get started. Let's talk about first the difference between populations and samples. A population is a group of people or objects that you want to know more information about. An example might be the American population, the American people. We want to know more about what Americans think about a given topic. Or we might take a sample of all pine trees and we want to know something about pine trees in general. Well, we couldn't look at every single pine tree ever, or we couldn't ask a question to every person in the American population. We have to take a subset or part of those populations. That is called a sample. There's lots of different ways that we can pick a population, that we can pick a sample, a subset of a population. Let's look at those different ways. The first way is a self-selected. So this is where members of a population can volunteer to be in a sample. The best example I can think of for this is where, if you ever watch the nightly news, they will quite often have a texting poll where they'll say, do you think that chocolate bars should be banned from schools? Text your answer. Well, that's self-selected because I can choose to text in or I can choose to not text in. Another type is called a convenience. Easy to reach members of the population are selected. So if I had an audience full of people and I was trying to take a survey, convenience would be, maybe I just pick the people in the first row and ask them a question about the information that I'm trying to gain. All right. Another type of sample is systematic. This is where we use some sort of rule to select members of a population. So we're moving that's a little bit more random, but it's not actually a random sample. So a systematic might be I pick every other person, or I call every 10th person in the phone book, or there's some sort of system for choosing people that I kind of stick to and adhere to when I'm sampling a population. The fourth one is a random sample. Each member of the population has an equal chance of being selected. And if you're looking for a representative sample, random is the best way to go. The other ones are not random, which is typically what you want if you want a representative sample of the entire population. Okay, let's talk about classifying samples. So let's consider this example. A sports writer wants to survey college baseball coaches about whether or not wooden bats should be mandatory in college baseball. Identify the type of sample used. So, in 1.1 here, the sports writer contacts only coaches he has phone numbers for. Well, if we flip back to what our types of samples, he's only looking at the ones he has phone numbers for. That's going to be a convenience sample, right? Because he's just looking at what's the most convenient group of people to contact? Oh, the people on my contact list. All right, so that'd be a convenience sample. If we look at 1.2, the sports writer sends a survey out to all the coaches and uses only the surveys that are returned. Okay, so he uses only ones that are returned. That's going to be self-selected because the members of the population, that's all the coaches, took the time to either fill out the survey or not, and if they decided to, they selected themselves. They volunteered to be a part of the sample. Okay, so that'd be a self-selected sample. Neither one of those are random. Sampling bias. So let's talk about bias in sampling. We've already kind of touched on it a little bit, where we talked about random and self-selected. And so an unbiased sample is representative of a population you want more information about. So for instance, let's say that we asked Mount Pleasant High School whether they supported, all the students in Mount Pleasant High School, whether they wanted open campus or not. We'd want a random sample would probably be the best, but we would want an unbiased sample, which means we're not picking a particular group that might have some sort of bias, I guess. A biased sample is a part of a population that's over or underrepresented. So in an unbiased sample, we would want to have the equal numbers of male and females, for example. We would want to have equal numbers of 9th graders, 10th graders, 11th graders, and 12th graders in our sample for it to be unbiased. If it was biased, maybe we ask only the males, only the boys in the school. Or if we asked only the seniors whether they thought open campus was a good idea. Those would be biased samples because one group of the population is overrepresentative. If it was the American population, it'd be like asking, only the people from North Dakota, a question that affects all of the American people. Those would be biased samples. Okay. So this section's a lot of kind of conceptual things where we look at populations and samples and analyze what type of sampling it is and if it's biased or unbiased. Now we're going to get into a little bit more mathematics. Quite often you'll see, there'll be a poll, and then at the bottom of the poll it'll say the margin for error for this poll is plus or minus 0.3%, or plus or minus 4%. So let's talk about how they find those margin for errors. This is the formula for margin for error. Margin of error is equal to plus or minus 1 over the square root of n, okay? And this is where n is equal to the number of people in the sample. Sorry, that's bad handwriting, excuse me. Number of people in the sample. Okay, so if you sampled 500 people, your n is 500. If you sampled 50 people, your n is 50. And so this gives us a quick way to figure out, if we take this sample, how representative of the entire population is it? The margin for error can tell us that. So let's do an example dealing with margin of error. Let's suppose in a survey of 1,011 people, 52% said that television is their main source of news. So we take a sample, maybe it's the American population, a sample of the American population, a subset, and 52% of the sample said that TV was their main source of news. Now the actual number could be a little bit more than that, it could be a little bit less than that. Let's figure out what the margin for error actually is. Okay, so we said we've got margin of error, we'll call it M of E. Whoa! Watch out. M of E is equal to, in fact, no, that's a bad idea. Let's just say error. Okay? Error is equal to 1 over the square root of n. And n is the number of people in the sample. So n is equal to 1, 0, 1, 1. Okay, so our margin for error, so don't forget the plus or minus. Our margin for error then is going to be equal to 1 over the square root of 1, 0, 1, 1, plus or minus that. And so that's going to be equal to plus or minus, I figured this out, 0.0315. Or if you were to convert that to a percent, it'd be about 3.15%. Okay? And so if you think about this, the greater your sample, the smaller your error. If this was the square root of 1,000,000, we'd have something like plus or minus 0.0000315. Maybe not that exactly, but it would be much, much smaller if we're taking the square root of 1,000,000 or the square root of 10 million. But we're going to find out pretty quick that you don't need to take 1,000,000 people to have a representative sample of even the American population. Sometimes a few thousand is all that you need, and this is only 1,000 people, and we've still got within 3.15% margin for error. So what does that mean? Give an interval that will contain the exact percent of all people who use the television as their main source of news. So if we can go plus or minus 3.15%, that means we could go minus 3.15, which would be 48.85%, all the way up to, if we add on 3.15, up to 55.15%. Okay, so somewhere in that range is the exact percentage. Because it was just a sample, it could be a little bit of an error. There could be 54% or 49% or whatever, but it's somewhere in that range. All right, last example here. If a polling company polled a population and the margin of error was plus or minus 5%, what was the sample size? So we're going to use that same formula where we say, all right, E for error is equal to 1 over the square root of n, and now I want to figure out what n is. My error is 5%. So instead of putting 5 in, though, I always use the decimal. So I've got 0.05 is equal to 1 over the square root of n. Okay? The first thing that I'm going to do is get rid of that square root because I don't like dealing with the square roots. To undo a square root, I'm going to square both sides. So when I square the left, I get 0.0025. When I square the right, I get 1 over n. Now, how do I solve this for n? The easiest way is to flip both sides, and then we'll have our answer. So remember that this could be written over 1. So when I flip both sides, I get n is equal to 1 over 0.0025. And if we move up here, we end up with n equal to 400. Okay, so they used 400 people in their poll. They used 400 people. So that's how we use margin for error. That's how we figure out what type of sample we're using. We looked at unbiased and biased sampling. And that's it for section 4.